PERT, Program Evaluation and Review Technique. It's event oriented. The objective of PERT is to find out whether a job could be finished on a given date. PERT are preferred for those projects in which the precise time determination for various activities cannot be made. That is, for projects where the activity timings, we don't know the exact activity timings. For such projects, we use the PERT. We use the technique PERT to find the project duration and all. Okay. Now it is since we don't know the activity timings precisely, probabilistic approach is followed for time estimation. So we will be given 3 time estimates for each activity. The 3 time estimates are optimistic time represented by TO, pessimistic time represented by TP, and most likely time represented by TM. By optimistic time is the shortest time the activity takes to complete for the activity to complete. So optimistic time is the shortest time the activity takes to complete if it has all the resources in time. Okay, and pessimistic time is the maximum time the activity takes under the most likely time. It is the time which occurs between the optimistic and pessimistic time. It is the time that the activity takes frequently. Now, using these timings, we can find the expected average time for the activity using the formula TO plus TP plus 4TM by 6. The time which we get using this formula is taken as the expected duration of the activity. Now let's see how PERT can be used to solve a network problem. Now this is the data given. First we have to draw the network and then find the given questions. Find the answers for the given questions. We have to find length and variance, then the approximate probability that the job will be completed in the given number of days. That is question 3 and 4. And finally, we have to find the due date, which has 95% chance to win. Okay, the details given are the activity is given with the event by specifying the events clearly. Then 3 timings are given. Since it's a PERT problem, we need 3 timings: the optimistic time, most likely time, and the pessimistic time. Now, using these 3 timings, we have to find the activity duration or the expected time using the formula T equal to T0 plus TP plus 4TM by 6. Okay, so first we will be finding the expected time for each activity from the data given. That is, from optimistic, most likely, and pessimistic time, we will be calculating the time duration, the activity time duration using this formula. So by applying the formula to each activity, we will be getting the time duration like this. Using this table, we'll draw the network diagram. So the first activity given in the table is 1 to the activity from events 1 to 2. Now look at the second one. There also the activity starts from 1. That means 1 is the starting event and 2 activities are emerging from 1. The first activity ends at 2 and the second one ends at 6. And the duration which we are going to write is, for the activity 1-2, the duration is 7. For activity 1-6, the duration is 6. Like this, we have to draw the rest of the activities and label the activities with the expected time. So after drawing all the activities, we'll get the network diagram like this. Now we have to find the TE and TL values for each event, only then we will be able to find the critical activities. So next we have to find the E values and the L values for each event. So starting with the E values, earliest event values, starting from the first event E1, since it's a first event, the value E value for 1 is 0. From there we will be finding the rest of the events E values. So the E value of 2 will be 0 plus 7, which is 7. Now E value of 3 will be 7 plus 14, and you will get 21. Now E value of 5 will be, to get the E value of 5, we need to find the E value of 4 also. Since two activities are ending at 5, we have to find from both the parts the E values and take the maximum of both the values, right? So before finding E5, we will be finding E4. For E4 we will get 7 plus 5, 12. Now from the path from 4 we will get the E value of 5 as 12 plus 7, 19, and from E we will get 21 plus 1, 32. So the maximum value is 32. So we will be assigning 32 to E5. Like this way we have to find all the E values of the events. Now the E value of all the events are written. Next we have to find the L value, which we will start from the last event. So the L value of the last event will be equal to the E value of the last event. So L8 is equal to E8, which is 36. From here we will be going backwards and we will find the L value of each event. Now from here L7 will be 36 minus 17, which is 18. And E5 will be, L5 will be 36 minus 4, which is 32. Like this we have to find the L values of the rest of the events. So these are the L values of all the events. Now we have drawn a network diagram, and we have found the values of we have found the E value and the L value of each event in the network diagram. Now using these values we can find the total float. So once we have found the total float, the activities for which the float is 0 will give us the critical activities. To calculate the total float and variance, we will be using the formula total float equal to Lj minus Ei minus D, and variance equal to Tp minus To by 6 the whole square. So we'll draw a table and find the values of float and variance for each activity using this table. Okay, so first let's find the float for the first activity 1, 2. For that we need the values of Lj minus Lj, Ei and D. Lj means J is the J indicates the head event and I indicates the tail event. So Lj minus Ei means L2 minus E1 minus D. So for the first activity, float Lj minus Ei minus D is L2 minus E1 minus D. So L2 and E1 can be obtained from the network diagram which we have drawn earlier. The value of L2 is 7 and the value of E1 is 0. So 7 minus 0 minus duration of the activity. The duration of the activity is 7. So minus 7 and we will get 0. Like this way we can find the float value for each activity using this formula. After that we can find the variance using the formula Tp minus To by 6 the whole square. So we can either draw a separate table like this to find the float and variance, or use the previous table and add 2 columns float and variance to find these values. Either way we can write. So the variance formula is Tp minus To by 6 the whole square, where Tp and To are given in the table. By substituting the correct values, we will be getting the variances for each activity. So for the first activity, let's see, Tp for the first activity is 15 and To for the first activity is 3. So 50 minus 3 by 6 the whole square, and we'll get 4. So using this formula, find the rest of the find the variance for the rest of the activities, and we'll be getting the values like this. Now to find the critical activities, to identify the critical activities, we know that the activities with total float 0 are the critical activities. So let's look which are the critical activities for this problem. The total float 0, mark the activities for which the total float is 0. So the first activity, we have a total float 0, so that is a critical activity. Okay, then we have a critical activity here, that is 2 for the activity 2, 3 also we get float 0. So 2, 3 is also critical activity. Then the next critical activity is 3, 5, then 5, 8. So we have 4 critical activities. We have 4 critical activities, and the critical path will be 1 to 2, 2 to 3, 3 to 5, and 5 to 8. These are the critical activities. So you can mark these critical activities in the network diagram. So the critical activities were 1, 2. So the critical activities are marked with the network diagram using double-lined arrows. So 1, 2 is a critical activity. Then the next critical activity is 2, 3. After that 3, 5, and the last one was 5, 8. So this is the critical path which we get 1, 2, 3, 5, and 8. Now to find the length of the critical path, add the durations in the critical path. So this was a critical path. Now add the values on the arrows of each activity. So 7, 14, 11, and 4. Sum of all these numbers will give the length of the critical path. So by adding that, we'll get 36. Similarly, to find the variance of the critical path, add the variance values of the critical activities. That is, the first critical activity is 1, 2. For that we got variance 4. So 4 plus 16 plus 4 plus 1 will give you the variance of the critical path, and that is 25. We'll get 25. So this is how we find the length and variance of the critical path. The third part of the question is to find the probability that the jobs on the critical path will be completed in the given number of days. Now to find the probability, we are going to use the formula Z is equal to T minus TE minus sigma. Which is the formula for standard normal curve. Now T is the value given in the question for which we have to find the probability. So here T is 41. Now T is the time duration of the critical path. That's the length of the critical path, which we have already found, which is 36. And sigma is root of variance, where variance we have already found, it is 25. So root of 25 is 5. So sigma is 5. Now we can find the value of Z. Therefore Z is equal to 41 minus 36 by 5, which we get as 1. Now to find the probability, we have to draw the standard normal curve, which is a bell-shaped curve. The center point of the bell-shaped curve will be at Z equal to 0, where the area on each half of the bell-shaped curve is 0.5. area on each half is 0.5. So when adding that means the total area of the curve is 1. 0.5 plus 0.5 will give you 1. So this is the concept of standard normal curve. So in this normal curve we have to find the area under z equal to 1. So first we'll mark the point 1 in the number line. So since 1 is a positive number, so we will be marking 1 to the right of z equal to 0. So let this be the point where 1 is. That means we have to find the area from 1 to the left end. That means we will be shading the area from the left end till 1. Since z is a positive value, we will be covering the left side completely. That means you are taking one half of the curve completely. This half we are taking this half completely. We know that each half of the standard normal curve is 0.5. The area on each half of the standard normal curve is 0.5. So this part will be the area under this part is 0.5. This region is 0.5. Now we have to find the area from 0 till 1, which can be obtained from the standard normal table. So I'll show you the standard normal table. This is the standard normal table. In this table we have to find the area under z equal to 1. The z values are given in the rows and columns. In the row headings and column headings, and the values inside this portion, inside the table, gives us the area under the curve. Okay, so we have to find the area under z is equal to 1. So look from the row and column headings, look at the value where z gives 1. Now in the column we can see that here z is 1.0. Since we have to find z equal to 1, it can be read as 1.0. The first column is 0. That means 1.00 is the value given by this cell. That is 1.00. So to find the value for z equal to 1, we will be taking the value at z is equal to 1.00. 0.3413 is the area under z is equal to 1. That means, as the figure shows, the value of z, the value under the value of z, the value under value which we get from this table will be the area covering from 0 till that particular value. Okay, so here for z equal to 1, the area we got is 0.3413. That means in the figure we have this portion is 0.3413. Now we want the area from this end, from the left end till 1, right? So the probability will be, if z is positive, the probability will be 0.5 plus 0.3413. Since z is positive, probability is 0.5 plus 0.3413, which gives 0.8413. So this is the probability that the job will be completed within 41 days. Like this way we can find the probability for 35 days. So here in the case of 35 days, T is 35, TA is 36, and sigma we have already found, it is 5. Okay, now Z will become 35 minus 36 by 5, which is minus 0.2. So while drawing the curve, this is Z equal to 0, and minus, since it is negative, we have to mark 0.2 to the left of Z equal to 0, and we have to find the area from the left end till here. But from the table we will get only the area from 0 to 0.2. Okay, So let's find the area from 0 to 0.2. So in the table, look for the value 0.2 under Z. So Z, we have 0.2 here. So 0.20 will give us a value at Z is equal to 0.2, which is 0.0793. So area at Z equal to 0.2 is 0.0793. Now, since Z is negative, probability will be 0.5 minus 0.0793, which is 0.4207. So looking at the table, we can see that since we want the area in the shaded portion and we know that each half is 0.5, we have to minus 0.0793 from 0.5. That is how we get probability equal to 0.5 minus 0.0793, which is 0.4207. So this is the probability that the job will be completed within 35 days. Now to find the next part of the question, that the probability to find the probability that the project will not be completed within 45 days. For that, we have to first find the probability that it will be completed within 45 days, and from 1 we have to minus that to get the probability that the project will not be completed within 45 days. We are using this formula since the total probability is 1. It is easy for us to find the probability that the project will be completed within 45 days by the above method. That the steps which we have used to find the probability in the third part of the question. The steps which we have done there can be used to find this part of the question, and by that method we'll get this thing which I have put in bracket, and subtracting that from 1 we'll get the answer for the fourth part of the question. Okay, so first we'll find the probability that project will be completed within 45 days. That means T equal to 45, then TE we already know 36, and sigma is 5. So is equal to T minus TE by sigma, and we get Z is equal to 1.8 by substituting these values in the formula. Drawing the curve, 1.8 is to the right of Z equal to 0. That means we have to find the probability of Z less than 1.8, which is 0.5 plus probability at Z equal to 1.8, which is to be found from the table, and the table value is 0.4641, and therefore we'll get the total probability. By adding these two we get 0.9641. Okay, so this is the probability that the project will be completed within 45 days. So the answer which we want is that the probability that the project will not be completed within 45 days is 1 minus probability that it will be completed within 45 days, which is 1 minus 0.9641, which is equal to 0.0359. Okay, so this is the probability that the project will not be completed within 0.0359, which can be represented as percentage as 3.59%. If the question is to find the percentage to represent it as percentage, just multiply this probability value into 100 and you can represent it in percentage. Now the last part of the question, where the percentage is given and we have to find the t value. Right, we know that z is equal to t minus te by sigma. Here the percentage is given, that is before in the previous questions we were finding the probability, that is the percentage value, and t was given. Here we have to find the value of t where the probability is given. The percentage can be converted to probability, okay, and by that way we can find the value of t. Here the given probability is 95%, right? So that means here the given percentage is 95%. That means the probability is 0.95. 95% can be written as 95 by 100. That is given probability is 0.95, right? We know that probability is the area, indicates the area under the standard normal curve. So, and each half of the normal curve, we know that each half of the normal curve is 0.5, right? The area on each half of the normal curve is 0.5. So if the probability is 0.95, that means it is greater than 0.5. That means one half is completely included inside the area, right? So one half is completely included and the remaining will be on the next side. So if the probability is greater than 0.5, that means the left half is completely included and the remaining area will be from the next from the opposite half, right? So if 0.5 is here, then the remaining half will be, just reduce 0.5 from the given probability, we'll get 0.45. That means here the area is 0.45. Now we have to find the value of z dash at where the area is 0.45. Since we know that from the table we'll get only the area from 0 till z dash. So and we know the area is 0.45 and we have to find z dash from the table. Now taking the table, the area portion is given inside the table. The values inside the table are the area. So in this area part you have to find where 0.45 is, or a value close to 0.45. Now looking at the table we can see that 0.45 is here, that is 1.65. we get 0.4505 and just before that we'll get 0.4495, which can be approximated to 0.45, right? So you can either take this or this. So now I am going to take 1.64. okay, so I'm going to take z dash as 1.64. okay, that means the area under 0.45 is 0.4, the area where 0.45 lies is the z value at 0.45 is 1.64. that means we have got the z value as 1.64 and we know that the formula for z is t minus te by sigma. The formula for z is t minus te by sigma. That means by substituting this, substituting the values, we know te, sigma and z now. Then we can find the value for t. So 1.64 is equal to t minus 36 by 5. And using this formula we can find the value of t, which is 1.64 into 5 plus 36, and you will get t as 44.2. that means the due date for which there is 95% chance is 44.2 days.